So that's half the battle, knowing what the variable stands for. Of a point moving with uniform circular motion, if s is 18 feet and t equals 3 minutes. So we can just do v equals s over t. If you're struggling with the units, you can write them in your problem. If I do that, 18 divided by 3 is 6. My units in feet per minute. Right, number 2. Find the distance s covered by a point moving with a linear velocity v equals 20 feet per second for time t equals 6 seconds. So again, v equals s over t. We do a quick check. Seconds, feet per second, so there's no problems there. So you just multiply over your 6. And s is 120. What are my units? Feet. All right, number 3, find the angular velocity. What's angular velocity? So omega equals theta over t. So my omega equals 60 pi over 3.4 hours, and what's that give us? And what would my units be? All right, so these were fairly straightforward ones. Did we do okay with those? Let's try one that requires a little more. Find s if r is 5 meters, t equals 1 minute, omega is 3 pi over 2 radians per second. So now what would we do? See any problems right now? T is in minutes, but my speed is in radians per second. So what should we do? Conversion. Let's just make our time 60 seconds. Okay. We need s, so we can do s equals r theta, but we don't have theta. Or v equals s over t, but we don't have v, so we have to use more than one formula here. What do you want to find? Theta, okay. So we can do omega equals theta over t. This is 3 pi over 2 radians per second equals theta over, I need to use the 60 seconds so that my minute or my units match. So then we can multiply over our 60. And we get theta to be 90. So now we can do s equals r theta. So s is 5 meters times the 90 pi. So we get 450 pi meters. Is that one okay? So that was an example of one that used a couple formulas. Let's try a problem where we have to read and figure out what information is being given to us. So if I said a lawnmower has a blade that extends out 2 feet from its center, what is this representing? The tip of the blade is traveling at the speed of sound, which is 1,200 feet per second. What's that? Through how many revolutions per minute is the blade turning? What am I asking you to find? Revolutions would give us theta, but when I say revolutions per minute, that tells me it's a speed, right? So I'm asking for omega, but in different units than usual. We're going to have to do some conversions. Okay, so we have to find omega first. We know V equals R omega. So omega is 600. Now, when you put theta or omega into a formula, they have to be radians, so that's what we get out. So this is radians per second, because my V was in seconds. I want revolutions per minute, so I'm going to practice my conversions here. All right, if I have radians and I need them to cancel, I just put radians on the bottom. I want revolutions. 1 revolution is all the way around the circle. How many radians is that? I have seconds, I want minutes. So what do I multiply by? 60 seconds and 1 minute. Okay. So those will cancel. So you could write it as 18,000 over pi, or 5,729.578. My units then would be revolutions per. So this one was really a couple of things. We had to find our omega, and then we had to do the conversions. Any questions there? I want to do just a couple more review questions. Take a second and try this. Our radius, the 18 seconds would be our time. What's the 76 centimeter, or 72 centimeters? So linear speed, V equals S over T. So you do 72 over 18, and what's that give you? All right, angular speed is omega. So we could do V equals R omega. So we know our V, we know the R. So if you divide by 12.96, what do we get? Sorry, I couldn't hear you. 25 over 80. Thank you. And that's radians per second. All right, are those okay? Last thing, I just want to practice some of these. We haven't in a few days. What work do I expect when I ask you for exact value? Quadrant and reference angle. 4 pi over 3. What quadrant is that? 3, because it's the top is 1 more. Reference angle is pi over 3, or if you prefer, what's that in degrees? Okay, in quadrant 3, tangent's positive, so cosine's negative. Then cosine of 60 degrees, where cosine's the square root of the bottom, over 2, so 1/2. All right, 7 pi over 4, what quadrant?
4.
Reference angle?
45 degrees.
Yep. Pi over 4 is 45 degrees. In quadrant 4, cosine's positive, so tangent's negative. What's the tangent of 45? Radical 2 over radical 2, so we get 1. 5 pi over 6, what quadrant?
2.
Reference angle,
Pi over 6.
pi over 6, or if you prefer, 30 degrees. In quadrant 2, sine is positive. What's the sine of 30? 1/2. Are we getting pretty good at doing these? Hopefully. Okay. 4 pi over 3, what quadrant?
3.
3 because the top's 1 higher. Reference angle is pi over 3, which we know is 60 degrees. Okay, cosecant's the reciprocal of sine. In quadrant 3, tangent's positive, so cosecant is negative. Sine of 60 would be radical 3 over 2, so cosecant would be the reciprocal, -2 radical 3 over 3. All right, 7 pi over 6, what quadrant is that? 3. Reference angle, 30 degrees, that's pi over 6. In quadrant 3, tangent's positive, so secant's negative, secant's the reciprocal of cosine. Cosine of 30 is radical 3 over 2. If we do the reciprocal, we again get -2 radical 3 over 3. Last one. What do we do if we have a negative angle?
Add 2.
So it's just like 2 pi would be, what's that give us once we have?
4 pi over 3.
So it's 6 pi over 3, so we add it, we get 4 pi over 3. So then that's quadrant 3. Reference angle pi over 3, or in quadrant 3, tangent is positive, so cotangent would be positive. Tangent of 60 is radical 3, so cotangent would be radical 3 over 3. All right, are we okay with those questions? This is my final slide. If you are between pi over 2 and pi, what quadrant is that?
1 and 2.
2. Just remember this is 0. So we're in quadrant 2. Reference angle. When is cosine 1/2? 60 degrees. Now, what is that in radians?
Pi over 3.
So then pi over 3 in quadrant 2 would be 2 pi over 3. Remember, in the second quadrant, the top is 1 less. All right, if we are between 3 pi over 2 and 2 pi, what quadrant is that?
2.
Reference angle. I need to know when cotangent is 1, or that means tangent is 1. So that is 45 degrees, or what in radians? Then pi over 4 in quadrant 4,
7 pi over 4.
double minus 1, 7 pi over 4. Does everyone understand how we're doing these? One thing, this negative here, it doesn't mean my answer is negative. It's only negative because in quadrant 4, tangent and cotangent are negatives. Okay, so that's only because of the quadrant. Last one, if I say 0 to 2 pi, I'm talking about every quadrant, but sine is equal to a -1/2. So we can be in any quadrant, but if sine is negative, which quadrants are we in? Okay, so we will have 2 answers. reference angle, when assigned 1/2. 30 degrees, which is, okay, pi over 6 in quadrant 3, so in quadrant 3 the top is 1 more, so 7 pi over 6. In quadrant 4, double minus 1 would be